Hey everyone, today I'll be scanning this capsule house showroom. The client asked me to design 10 side canopies, so I'll walk you through how to create canopy structures directly around the 3D scan data using BricsCAD. I'm setting the SHARE S20 on a level ground and pointing it toward the showroom building. I need this scan to be georeferenced, so I'm switching on the RTK. I'll be scanning this in point cloud mode. I'm not going to walk in an S pattern this time. I'll be walking in a loop instead. These capsule houses have walls that sit flush with the roof, so there is no real protection from sunlight. In Thailand summer, solar load can reach around 400 watts per square meter. Even though the walls are insulated, the large windows let in a lot of heat, and curtains alone aren't enough to block that level of solar gain. When designing a sunshade canopy, the model needs to be aligned to true north. That way, you can accurately simulate how the shade will fall at different times of the day throughout the year. When scanning with RTK, you capture not only the GPS coordinates of the point cloud for locating the foundation layout, but also the orientation of the scan aligned to the true north. I want to integrate the overall environment into the design, so I will scan the side facing the road. That way we can see how the canopy will look from the driveway. The owner wants the canopy to have a low visual impact. The capsule house should still stand out even after it's covered. The scan took 3 minutes, covering a travel distance of 154 meters. The next step is to remap the point cloud in SHARE Point Cloud Studio. This one's running on version 2.4 beta. I'm turning on the GNSS Fusion option and selecting the correct coordinate system. On the west side of Thailand, we use WGS 84, zone 47N. I'll also offset the ellipsoidal height by 30 meters to bring it closer to the mean sea level. Since I'm not doing a 3D Gaussian splatting, I'll turn off the undistorted photo output to save storage space. Now I start the calculation with the outdoor scenario selected. And here is the result. Everything looks good. There is no ghosting and no double walls. If you are within 5 meters of the object and pause for a few seconds at each spot, you will capture a dense photo-like point cloud. The trade-off, of course, is longer scanning time. The point cloud quality is good enough for client presentation, so I will design the new canopy directly over the scan without modeling the entire environment. This is one of the most useful features of a SLAM LiDAR scanner in my workflow. This approach cuts down the time needed for the primary design. If I had to model the environment in CAD first, it would take longer than designing the canopy itself. This is BricsCAD, the lowest cost CAD tool that can import point clouds directly from a 3D scanner. Even with a massive dataset of over 200 million points, you can still orbit the viewport fluidly. Each point in the clouds is aligned with GPS coordinates, including the orientation to true north. It also has an option to overlay the street map onto the point cloud. This makes it easy to trace the road network and integrate it into the master plan without actually scanning the road in 3D. I'm going to pick this point between the two capsule houses and move the point cloud to the origin. Since I'll be running a structural calculation later, it's better to work around the origin point, and I can always move the cloud back to its georeference position afterward. Here, I'm setting the canopy's center line and roof boundary. The east side will have a longer extension because the showroom building behind provides shade from the afternoon sun. I have worked out the roof form and adjust the height. You will notice I orbit back and forth quite a bit to evaluate the proper roof shape in relation to the surrounding environment. This is my workflow for designing canopy structures. I start by defining the roof boundary, then create the roof forms using 3D lines. Those lines are used to run the calculation model which generates the tensile fabric shape. This fabric shape was simulated in a dedicated software, then imported into BricsCAD. BricsCAD also includes a steel frame generator. It's not as advanced as Autodesk Inventors, but it's sufficient for this stage. I'm not detailing the steel here. This is just the preliminary design phase. Here I can only trim and join straight steel members. If a member is curved, I need to trim and notch it manually. Maybe in the future video I will demonstrate steel detailing in BricsCAD, but from what I can see it will take considerably more time than in Autodesk Inventor. Now I'm moving on to the second canopy, which will cover this triangular capsule house. To locate the canopy properly, I will run the sunshade simulator in BricsCAD starting at 9 AM, the time the showroom opens. The sunshade isn't covering the required area, so I need to shift the canopy to this side of the house. Now the sunshade covers more area than when it was placed on the right side. This fabric form was generated in a specialized software and then imported into BricsCAD. And here's the final step, adding the steel members. You will need at least the BIM version of BricsCAD to access this feature. Designing directly around the colorized point cloud makes the process much easier. You gain abundant 3D information from the surrounding environment, which allows you to explore more ideas and creativity compared to working from 2D as-built drawings. I started at the job site at 10 AM. and was able to finish this drawing by 3 PM, saving significant amount of time. If I were using a total station, I would still be out at the job site. This technology is truly a welcome change for me. Thanks you guys for watching. I'll see you in the next video.